Hello guys, welcome to the mathematics lesson. This is the mathematics lesson 12. In today's lesson, we'll be looking at finding the arithmetic mean of an arithmetic progression. Finding the arithmetic mean of an arithmetic progression. So what is the arithmetic mean? The arithmetic mean of an arithmetic progression is the middle term of the arithmetic progression. So the arithmetic mean is just the middle term of arithmetic progression. So the middle term of an arithmetic progression is just the arithmetic mean. If A, B, and C are the terms in an arithmetic progression, then the arithmetic mean is B, the middle term. A, B, C being the terms of an arithmetic progression, then the arithmetic mean of ABC, it is actually B, the middle term. So the arithmetic mean is the middle term of the arithmetic progression. So since the three terms A, B, and C are the terms of an arithmetic progression, it means they have a common difference. Remember previously when we looked at what arithmetic progression is? These are sequences in which the consecutive or successive terms of the sequence have got a common difference. So such a sequence which have a common difference between successive terms of a sequence, then we call such a sequence as an arithmetic progression. Then here we are saying, since the three terms A, B, C are terms of an arithmetic progression, it means they have a common difference. So now, you are given an arithmetic sequence, for example, an arithmetic progression sequence, then the middle term of that sequence is called the arithmetic mean. So B minus A is equal to C minus B. Alright, so what we are saying, given these A, B, C as the arithmetic progression, and saying that these being an arithmetic progression as a sequence, then they have a common difference. And then since they have a common difference, if you get B minus A, it's the same as getting C minus B. That's what we mean here. For instance, let's say we have 1, 2, 3 as a sequence. Alright, or as an arithmetic progression. What we mean is if we get 2 minus 1 is the same as 3 minus 2. Because if we say 2 minus 1, we get 1, equals if we say 3 minus 2, we get what? 1. This is the same way if we have A, B, C. We are saying if this is an arithmetic progression, it means it will have a common difference. And since it will have a common difference, if we get B minus A is going to be the same as when getting C minus B. Now, we know that B is the middle term and it is called the arithmetic mean. So how do we find the formula for finding the arithmetic mean? Because we are looking at finding the arithmetic mean, the middle term. So in this case, since B is the middle term, using this algebraic equation, we are going to collect like terms together. We have B on the right side of the equal sign or left side of the equal sign. So we have B plus B is going to be equal to C. Then this crosses the other side plus A. Then B plus B to B equals C plus A. If we are to remain with B, we divide by 2, even here by 2. Then B is going to be equal to C plus A over 2. So this becomes an expression for finding the mean. Alright? So we are saying this becomes the formula for finding the arithmetic mean. Now let's look at this example. Example 1 says, 1. Find x and y if 16, x, 6, and y form an arithmetic progression. So we have this as an arithmetic progression, and then we are being asked to find x and y in this arithmetic progression. And then 2, the numbers m minus 1, 4m plus 1, and 5m minus 1 are 3 consecutive terms of an arithmetic progression. Find the numbers. What are these numbers? So let's start by answering number 1. So This is the sequence or the arithmetic progression given. So we know that we are being asked to find what? Find x and y. So we are going to use the concept of arithmetic progression, arithmetic mean. So we'll say, we know that b is equal to c plus a over 2 for 3 consecutive terms of an arithmetic progression. Now, if we are given 16x, y, 6 and y, then what are we going to do? So what we are going to do here is to get 3 first, so that we get x as the mean, arithmetic mean. So if we consider 3, where we get 16x and 6, then the arithmetic mean, which will be now x, and x will be found by x is equal to, we will get 16 plus what? 6 over 2. Then we are going to solve for x. So we are going to say equals x is equal to 16 plus 2, which will be 22 divided by 2, equals x equals 11. Because 22 divided by 2 is 11. Meaning we have found that x is now what? 11. So here now we are going to have 16, 11, 6, y. Let's find for y. So what we are going to do again here is to consider these 3 here, starting from 11, 6, y. And on these 3, 11, 6 and y, 6 is the arithmetic mean. So we are going to say 6 is equal to, we'll get 11 plus y over 2. Then what we are going to do is to make sure that we eliminate the fraction by saying 6 also over 1. So we are going to multiply 6 by 2, which will be 12, equals 1 times 11 plus y, which will be the same 11 plus y. Then what we are going to do is to collect the like terms. So what we are going to say is to say that 11 plus y is equal to 12. We start rewriting this with the term containing the unknown. Then we are going to say y is equal to, we collect like terms, we have 12, so 11 crosses on the other side. Then we say y is equal to 12 minus 11, which will be 1. That means y is equal to 1. So we have found these. We have found x and y. So we are going to say the arithmetic progression is now 16, 11, 6, 1. Does it make sense? Yes. Because this one becomes an arithmetic progression because the common difference is the same. Let's prove this. So we are saying the common difference is the same, because if we get 16, the difference between 16 and 11, 16, 11 is what? 5. Let's speak again the difference between 11 and 6. So 11 minus 6. What are we getting? 5 again. Again, let's say we get 6 minus 1. What are we getting? 5 again. So this one is truly an arithmetic progression because they have a common difference between 2 successive terms of the arithmetic progression. Alright, so this is how we find such questions. So let's look at question number 2. So question number 2 says, the numbers m minus 1, 4m plus 1, and 5m minus 1 are the 3 consecutive terms of an AP or arithmetic progression. Find the numbers. We need to find all these numbers. So we are going to use the same mean. So we are going to say solutions T. So we are going to get these as the terms of the arithmetic progression, we know our formula should be b is equal to c plus a over 2. Then we'll get these as well. So here the middle term is 4m plus 1. So say 4m plus 1 is going to be this one, 5m minus 1 plus m minus 1 over 2. Then what we are going to do here is we are going to say 4m minus 1 is equal to, then we'll collect like terms, 4m and 2m, I mean m, 5m and m. So 5m plus m, then minus 1 over 2. Then we'll say 4m plus 1 is equal to 5m plus 1 plus m is going to be 6m. Then minus 1 minus 2 over 2. Then we are going to get rid of the fraction to find the value of m. So say over 1. When we cross multiply, we'll say this times this. So we have no space here, right? So let's move here. So we are going to say this by that. It means 2 times that. So say 2 times everything in the brackets. We'll put this in the brackets. Then equals 1 times 6m minus 2. It will be 6m minus 2. Then we are going to do what? To get rid of the brackets. So multiply 2 times 4m, 8m, plus 2 times 1, 2 is equal to 6m minus 2. Then we are going to collect like terms. So m6 will cross here to become minus 6m equals, then here we have negative 2. This negative crosses becomes negative 2. Then 8m minus 6m, we get 2m equals minus 2 minus 2, it will be minus 4. We'll divide by 2 to remain with m equals, here we divide by 2 to get negative 2. It means m is what? M is negative 2. Now that we have found that m is negative 2, now we can replace it here and here and here to know the whole term here. So here we'll say m minus 1. Let's substitute where there's m here. Let's put negative 2. So it will be negative 2, negative 1. Negative 2, negative 1, it will be negative 3. So this term is negative 3. Then we'll pick this one also, 4m plus 1. We'll substitute 4. Where there's m, there's negative 2 plus 1. Then 4 times negative 2, negative 8. Then plus 1. Negative 8 plus 1, negative 7. So this term is negative 7. Then we'll get this one, 5m minus 1. We are going to say 5 times m is negative 2. Then minus 1. 5 times negative 2, negative 10, minus 1. Negative 10 minus 1, negative 11. Then we have found now the numbers. Find the numbers. So we're going to say the numbers are negative 3, negative 7, and negative 11. We have come to the end of this mathematics lesson. Next, we are going to look at the sum of the arithmetic mean in the next lesson, the sum of an arithmetic progression. Thank you for watching and see you in the next lesson. As for now, bye.